Hello everyone, welcome back to my YouTube channel. So in today's video, we are going to see a differentiation between DevOps role, SRE roles, platform engineering roles and cloud engineering roles. There are a lot of people who got confused with these roles. So in this video, we are going to explore or understand the use case, the function, the role of each particular role. Before moving to these roles and explain, first let's see why all these roles matters. As we know, modern software systems are consistently changing. They build like they are basically built to handle millions of requests, features, releases, and every day you will see new technologies coming up. So to handle this much load, each or specific roles has been emerged. So like DevOps will do their jobs, SREs will do their jobs, platform engineers will do their jobs, cloud engineers will do their jobs. So like single role cannot handle nowadays complex IT systems. That's why we required these many roles in market. And if you apply for any a company, or maybe you will get an email from any HRs, you will see a description, job description. Basically there are many tools which will be common, but as a DevOps engineer, as a SRE, as a platform, as a cloud engineering, mostly you will work on common tools, but the use cases will be different. For example, as a DevOps engineer, I have assigned to create a CI/CD pipeline. So my job is to create a complete CI/CD pipeline from dev environment to production environment. Till productions, DevOps manage, they have deployed everything, they have done it. Now the job start for SREs. Similarly, we have for platform engineers, cloud engineers, they have their own roles. So that's why the single role cannot handle everything. That's why these are the four roles which are very popular in market, and every role has their own use case or own particular things to do. Let's understand each role one by one. So we'll start from a DevOps. So as we know, DevOps is not a tool. DevOps is a culture, is a practice, or maybe we can say is a mindset, which basically bring developers and operations teams together. And basically it will eliminate the gap between development and operation teams. And the end goal for DevOps is for faster delivery, better collaboration, automation, and continuous feedback. Common practices, if I'll talk about, so they have to create CI/CD pipelines, they have to create infrastructure as a code, they have to set up monitoring and alerting, they have to basically remove slots from between the teams. So DevOps is basically removing the gap between DevOps and operations, so it can deliver the software or application much faster way. So it is a collective effort of both the teams, development and operations. Now let's see a DevOps flow. This is I would not say it's a proper complete flow, but I have tried to put most of the things which generally DevOps people do. So the very first thing is requirement and goals. So for that they generally use tools called Jira, Trello, Azure DevOps board. Second, develop and commits. For that they use Git ID, or maybe Visual Studio Code, or Visual Studio itself, Eclipse. So there are many IDs available. So if you can see in complete workflow, few things will be done by development, few things will be done by DevOps, but in general, if you have to set up a Azure DevOps board, that is a job of DevOps engineer, and developers basically will use that board to create their user stories, test cases, whatever. In the second thing, develop and commit. So basically here we are doing development and commit. So again, here developers will be responsible for writing their code and checking their code on a GitHub repo, but the job for DevOps engineer will be to manage a GitHub or maybe any repository which they are using, like any distributed systems which they are using, like manage their access, lot of things, repositories, permissions, lot of things basically will be done by DevOps. So again, here in second stage, developers and DevOps both are working together here. Now third is compile and package. So again here DevOps and development teams is involving, because DevOps people will set up the CI/CD with the tool like Jenkins, Azure DevOps, GitLab, GitHub Functions, and the code compilation, like developers basically let DevOps to know, okay, how basically this code will be built. So again, both the teams are working on these stages. Second is automated testing. So again, developers will write the test cases and DevOps will set up a tool to execute those test cases. Then we have artifact management. So again, developers will generate the artifacts, but DevOps will set up the artifactory tool for them. Automatic deployment. So here basically majorly work from DevOps engineer sites. They have to set up Kubernetes, Docker, Ansible, Terraform, like lot of tools for automatic deployment. Another stage is run applications. So for that they generally use any cloud provider tool like AWS, Azure, AKS, EKS, whatever, and configuration management tools. Then we have collect metrics and logs. So for that, DevOps engineer basically set up Prometheus, Grafana, ELK stack. So these are the many tools available in the market. I have just mentioned few here. So if you can see in overall workflow, basically both the teams, development and operations, they both are working on this this flow. So few stages dev and ops work together. In few stages DevOps or operations only work. So like automated deployment setup, applications, logging, so everything will be set up by DevOps. So majorly DevOps will set up entire CI/CD pipeline so that developer create or generate their artifacts as soon as possible, and it will basically reduce the error as well. Like if you are using a continuous integration and continuous deployment, then you can easily detect the any issue or any error in an early stage as well. So end of the day, whatever the application you are building, that will be mostly work free. So this is the DevOps flow. Now let's talk about site reliability engineer, in short we call as SRE. So basically SRE is invented by Google. It's DevOps with basically SRE is also a DevOps, but strong focus on system reliability. What does it mean by system reliability? So whatever the application DevOps engineer deployed on productions environment, now that application should be used by customers. So the job of SRE is to continuously monitor that of applications, like there should not be any performance issues, like the application should be highly available, reliable, scalable. So that's the job of SRE basically. So they majorly focus on monitoring and observability part, because suppose, for let's take example here, suppose I have created one product. Now I will not use that product for myself. I have created that product for a market. Now if I will go to market, there are many competitors for that particular product. Now I need to create a differentiation between my product and other product as well. So customer can will be more interested for my product compared to other vendors or other competitors. So for that, what they do basically, we will sign a SLO, which is called service level agreement. So on that, so that is a particular document basically. So there are many things which is mentioned or which basically keep us up in compared to other competitors. Like we defined, okay, I will provide 99.99% uptime for my applications. My application will handle millions of requests in particular seconds or particular minutes. So all those basically contract we are going to sign with customer. So the job of SRE is more important, because if the contract, whatever the things you have mentioned in your contract, like 99.99% uptime and millions of requests you are going to handle in this particular minute or seconds, whatever the duration you have assigned or defined in the document, so you have to meet those particular requirements which you have committed with the customers. So for that, SREs are responsible to maintain the reliability, scalability and high availability of the applications. Basically they work on 24 by 7. So in case if is there any issues, they have to immediately look at it, because if my application is going to down and it is breaching the service level agreement which we have signed with customers, in that case my company or myself has to pay a penalty to the customers. So that's why SRE job is more important. Now let's see a workflow of SRE as well. Okay, so the very first thing, define SLOs and SLIs. So this is service level object, this is service levels indicators. So these are defined by SREs. So for that they generally use tools like spreadsheets or maybe internal documents, because this is kind of a letter or agreement which we are going to sign with customer or end user maybe. Then they set up a monitoring and observability tool like Prometheus, Grafana, and etc. So they will continuously monitor the application performance or is there any issues. So 24 by 7 they will basically monitor the applications. They have set up a lot of alerts, like if maybe my RAM or maybe CPU is going beyond this percentage, which can slow down my applications. So for that purpose they basically create multiple alerts. They also set up custom alerts. They also use built-in alerts which provided by these tools. So their job is basically 24 by 7, because they are responsible to meet the commitment which they have committed to the customer. Third stage is detect incident. So for that they use tool called PagerDuty, Opsgenie, VictorOps. So there are many tools which they use for detection. Like if there any incident, so to detect that incident they use these tools. Another one is incident response areas. So for that use Slack, Microsoft Teams, ServiceNow. So maybe if something goes wrong with my application, they will immediately jump to the call like through SLK or Slack, sorry, Microsoft Teams, and they will see what is the issue, what is the RSTA, like all those things they will discuss, and they will try to fix that error or issue as soon as possible. Because if they will not do a quick response, in that case they are breaching the service level agreement and company needs to pay a penalty. Another stage is, so they have reported the incident like using Slack or Teams, because when we use a detect incident tools, they will direct send a communication or a thread to maybe or email, Teams, like whatever you are using. So people got notified and they will immediately jump on a call and see what is happening. Another stage is root cause analysis and postmortems. So for that they use some kind of templates, like what was the issue. So basically they will identify the issue, they will write it down, and like for future reference, like basically they will do complete postmortems. Another is implement reliability improvement. So whatever the RCA they have captured on this stage, and they have created the template. Okay, we have seen these issues. Now how we can improve this, like in future we will not face a similar issue again. So they will do some improvements here. Then we have automate toil and operations. So they will try to basically set up a complete automated environment. For that they have to write some custom scripts, uh, any tools they can use for that. Like again, it's depend on what kind of a script they are going to write. So they basically avoid any manual intervention, like they want everything should be automated, so they can avoid any human error as well. Then we have capacity planning and performance. For that they use JMeter and locus. So what does it mean basically? They will do some kind of test load on their applications. Okay, I'm putting this much load, if is my application is capable to handle this much load. So before handing over to customers, first they do a lot of things, like they will check a performance, like okay, maybe I'm sending millions requests, now my application is capable enough to handle that particular requirement. So for that they always do some capacity planning. Maybe if in future they can expect, okay, 20% more I can assume on this or traffic on this applications, so they will reserve some capacities for that particular time period. In case if they hit that limit, they will immediately increase the capacity, so the application performance. And before that they also do some kind of testing, artificial testing, to check the application health and performance. Then review and refine SLOs. Then they will review again and refine the SLOs as well. So this is the basically a continuous reliability loop. So if single incident happen, they basically go into complete flow. They will improve, they will see what was the issue, they will define RCA, they will do postmortem. So a lot of things basically. So this is the never ending loop, because we are using nowadays, everybody is dependent on internet, and we see most of the applications are 24/7 up. So these are basically managed by SREs, who make sure the commitment which they have done with client or customers. Now let's talk about platform engineering. So platform engineering is equal to developer enablement. What does it mean basically? So the job of platform engineering is to set up an internal environment for developers, so they can produce, or basically they can do like whatever they want to do. Like they have to deploy, they have to write, they have to generate the create the infrastructures. So in product engineering basically we use some the team basically set up some kind of tool, or I would say ID, like any platform basically, which developers can use to set up anything. Or at end of the day, developers job is to deploy their application. So for that the team basically set up some kind of tools which with predefined template. Okay, so for example there will be a CI/CD pipeline already predefined. They have to simply go click, select the environments and deploy. So ready to use product basically, the platform engineering. Because for the platform engineers, the customer is the development team. They have to make things easy for developers. That's the main job of platform engineering. So as I mentioned here, the typical offering: ready to use development environments, dashboards, logging, observability, infrastructure provisioning tools. They build the toolkit so other can focus on coding. So the primary goal of platform engineering is to make a life easy of development teams, so they can completely focus on application code writing. And if they want to test something, if they want to deploy something, they simply go to this particular tool, they will select their requirements and all done. So because they are not aware how Terraform works, how Azure work, how AWS, how Kubernetes works, because their job is to write a code. So for them to make it easy to deploy anything, It could be anything like infrastructure provisioning, deployment of applications. So for that, platform engineer generally set up some kind of tools which they can use to deploy their applications. Maybe they have to run some kind of a script on databases. So these are the job of platform engineers. They are morely focused for development teams. So if you can see, the DevOps job and role was different, SRE's role was different, and platform engineering's role is different. Now let's see a platform engineering flow. So it is a continuous product development cycle for internal product. So they basically first understand the internal developers need and their pain points, where they are is actually struggling. Then they will basically design the platform like components or services. Then they will build and integrate platform components. Then they will do a test and validate that platform. They will create a documents, and they will onboard a team or developers so they can use like as a self-service basically. So they will not be dependent on the platform engineers. They will do their jobs, or like whatever the job of platform engineering, like DevOps generally do the deployment and all. So they can do from there itself, like self-service basically. Provide support and guidance, gather feedback and monitor uses. Then again, if they will get any feedback or enhancement, they will again go to this loop. So again, this is also a continuous loop which platform engineers follow. So the end goal of platform engineers is to make a life easy for development teams so they can completely focus on application code writing. Now let's see about cloud engineers. So cloud engineers, or we call it cloud infrastructure experts. So their job is design, deploy and manage cloud-based systems. It could be AWS, Azure, GCP. So they are basically cloud experts. So they do, if suppose today I'm using on-premise data centers. Now I need to migrate to cloud. So their cloud engineers plays an important role because they know the cloud services. They know how we can migrate the existing stuff to cloud, what all the challenges we can face, what all the enhancement or modifications we have to do before moving to cloud. So everything managed by cloud engineers. So like platform engineers, sorry, infrastructure provisioning, like they need virtual machines, containers, networking, databases, security and compliance, cost optimizations, troubleshooting cloud environments. So these are the focus area for cloud engineers because they are cloud experts. They know much more about cloud compared to platform engineers, SREs, or DevOps engineers. They use tools for like Terraform, Biceps, cloud formations, or maybe native cloud services for provisioning the resources. So if they are they are mostly administration sites. If we will see, like if we have to create a RBAC role, we have to assign permissions, same time we have to manage complete infrastructure. So all those things basically will be managed by cloud engineer. And you will see in most of the organizations, cloud engineer team will be different. Even my company where I am working right now, I have different cloud engineering team. We call as CE team. We have a separate DevOps engineering team. We have separate database team. So we don't have a platform engineering team, but we do have to have SREs team. So there are different roles because single role cannot handle everything, because nowadays the modern software applications are more complex. They need specialized people for specialized things. So that's why there are many roles for to handle this much complex applications. Now let's see cloud engineers workflow as well. So So the main thing in cloud engineering is the provisioning, designing, architecturing, implementations, everything comes under cloud engineering flow. So the very first thing is understand project requirements and constraints. First, they will identify what exactly their requirement is. Based on that, they will provide us suggestions, because accordingly they have to design the architecture as well. Then they will design the cloud architecture. Okay, I need to use private subnet on this particular service, and I need to use public subnet for this particular service. Maybe we have to use this load balancer. So a lot of things basically. So all the architecture level things will be done by cloud engineer role. Then they will implement infrastructure as a code, because nowadays nobody basically create infrastructure using a portal. So they generally write infrastructure as a code. For that they use tools like Terraform, cloud formations, RM templates. Lot of things are available, so they use those tools. Then they will basically configure and secure cloud services, because security is also a very big challenge. Then they will deploy and integrate application services. Then they will monitor the infrastructure, because they have to manage the cost. If some resources are sitting idle, definitely they have to go and look, because unnecessary they are costing. And optimize and scale resources. So again, this flow is almost continuous, because requirements comes every day. They have to act on accordingly. They have to design thing, they have to provision thing, they have to configure, they have to in place a securities as well. So a lot of things basically handled by cloud engineer. If you think, if DevOps can do their job, SREs, platform, cloud, they can't handle. So that's why each role has their own task which they perform in each organizations. So now how these roles work together. So one thing, end of the day, the goal of each role is customer happy, because they share a common goal, because somehow they are using almost similar services but in different way. So DevOps is the foundation, the culture, the principle, the mindset, or the practice we can say. SREs apply DevOps principle to keep system running reliable. So you can see a dependencies. SREs are applying the principle of DevOps. DevOps principle, my bad, to keep systems running reliable. Platform engineers build internal tools and platforms that enable DevOps and SREs to scale. Cloud engineers build the underlying infrastructure that power everything else. So each role has their own job which they have to perform, but end of the day the success is a shared success, because DevOps is also involved, SREs is also involved, platform engineers is also involved, cloud engineers is also involved. So the, that's why I have mentioned shared success equal to shared goal plus strong communications. Definitely the collaboration, communication should be strong across the teams, so we can create a great product. So that's all for today. I just want to create a video that on this differentiation part, because myself itself got confused in early days when I got to know about these roles. And I have seen many people who generally got confused, because they just simply go and look for the job descriptions, and they see, okay, for DevOps also their requirement or skills are same, for SRE is also same. I don't know what companies are doing nowadays, but actually it is not. They are very specific about particular job and role which they are offering. So I hope it's clear. In case if you have any concern or doubt, you can definitely ping me over comments. Maybe if I have missed something on this video, you can definitely let me know in a comment box. That will be very helpful as well. So that's all. See you in next video. Thank you so much.